adding and subtracting rational expressions, but we're also like multiplying and dividing rational expressions. So it takes 8, 4, and 8, 5, and you mush them together. This is called a compound fraction, when you have a fraction on top of a fraction. So something like 1/2 over 5, or like 1/2 over 4/5. Okay, this is bad. We never ever want to leave, or even what's worse is when I see stuff like this.
Oh yeah, that's just trash.
Don't do that.
Or
like this.
That's just beluga.
Okay, these are not things that we do in
What
math.
is that?
You do not do this. So if ever you're doing math and you get an answer like that, you need to keep going, okay? Your answer should always be either a rational number or an irrational number, but it shouldn't be a combination of the two, or multiple. So, again, we have an issue here okay, with the x's and the y's. So what we're going to do is we're going to focus on this like one piece at a time. So first we will simplify the numerator. Then we will simplify the denominator.
But you got a 1 over y and a 1 over y, so.
And then we will put them together. So the numerator is 1 over x plus 1 over y. We need to combine that into one fraction. Right now we have 1, 2, 3, 4, and then 5 fractions. Bad. We want one thing, okay?
We want a thing of belugas.
So we're going to combine using what we did yesterday. So we need to find a common denominator in order to combine the fractions. So, yeah. By a y over y. Yep.
And then 1 over y times x.
Yeah. So that the common denominator is xy. We usually put that in alphabetical order. So if you're wondering if it's xy or yx, it should be xy. So with the common denominator, this guy has a numerator of y, this guy has a numerator of x, so we have y plus x.
Oh man, what did I just do wrong? Okay.
Y looks kind of weird.
Wait, I have a question.
Yeah.
Why did you do that?
We're taking two fractions and we're putting them together as one fraction. That's
Oh, so you're like adding them
does.
and then.
Yeah.
Oh.
We're just adding fractions together. So we have to find a
Just
common
without
denominator.
numbers.
Correct.
Okay.
And we're going to do the same thing to the denominator. So, denominator is 1 over y plus 1, which is 1 over 1. When we add fractions, we have to, add fraction to fraction, not fraction to whole number.
This takes up so much space already. This is so bad.
Do what I'm doing and it'll take up, oh, well, you're not on the notes, so you can use as much space as you want. Alright, I'm going to find a common denominator. What's my common denominator?
Y.
So I'm going to change this to y over y.
I wrote
1 over 4.
that was literally nowhere even near. That wasn't even close.
1 plus y over y. Be that guy. So simplify the numerator, simplify the denominator, and then you're going to put them together. So, because this is division, right? This technically means divide. We're taking blue and dividing by red.
Oh, they're
we're gonna
over each other now?
Well, they were always over each other,
Well,
see?
What?
No? You don't see?
I see
I
now.
see it really clearly.
That's why I
don't know how
color
to-
coded. So ready? Follow me? Ready? Are you following?
Yeah.
It was blue divided by red, or blue over red. So I simplified blue, I simplified red. Now we're going to simplify. So I have blue, and then
My face is weird.
divided by
I itched myself, but I'm
What?
done. But like I can.
red.
I'm done.
Not from here.
Good.
Blue divided by red. See that?
Mostly.
Now what's the rule for division of fractions?
You changed
You change flip,
Hold
or
on, I
multiply by the
colored this.
reciprocal. So that's what we're going to do. We're going to multiply by the reciprocal. I have y plus x over xy. Then I will multiply by the reciprocal.
Alright, hold on. Y plus x. I just feel like this just looks harder than it is. It's just a lot of unnecessary.
I said that yesterday. Do you remember me saying that yesterday?
I don't.
Oh, that looks bad.
It's
I was
honestly
like, it
just
looks harder
simplifying.
than it is.
It's just simplifying.
Now, from here, in some situations you might be able to like factor. So if you go back to section 4 when we were multiplying and dividing rational expressions, remember we could like factor and cancel. In this situation, there's nothing to factor, but we could possibly still cancel. So there is a y here and a y here, so diagonally we can cancel a y.
Even though the y is attached to the x though?
So attached, it's like this. If I were to combine these fractions, ignore this, we'd get y over xy. If this was 1 and this was 1, right? And we combined,
Yeah.
this is like y divided by y. So you can cancel those. It would be the same as if I did like 2 over 3 times 2. You can cancel these.
That's true.
So it's the same idea. Now, what you can't do is when it's like this. You can't cancel the 2's in this scenario.
Why not? So I can't cancel the y's across?
Because 2 over 5 is not the same as like 1 over, I don't know, 4? What would you have said? Right? Or 1 over
Did you
3?
just get it from you?
Like if you cancel, that doesn't make sense, but it makes sense here.
Is he okay?
1 over 6, or 2 over 6 is the same as 1 over 3.
So we can cancel all of it.
You can only
You're right.
cancel
I'm alright. I got it.
factors.
Okay.
You can only
What?
cancel factors.
She's just coding.
So we can cancel these x's. What we can't do, okay, looking the other way, we can't cancel like this y and this
Y.
y.
That
Because
bothers me so
Because
much.
this is a y plus x. This is a y plus 1. We can't cancel those. They're not the same
Can you get rid of the
factor.
1?
Wait, that's so weird though, because like you're like usually in a situation like that, it'd be the other way
Oh.
around.
Yeah.
Dang it.
You know what I mean?
I agree.
No, I don't.
Yeah, because usually you could like
It's usually
subtract
like-
the y.
Yeah.
Yeah. Oh well, who cares?
Neat.
So you just have to multiply them if
But
you
what
can.
did you just do?
Multiply.
Oh, I
You
was
just
like,
have to suck it
what?
up.
And then if you want to distribute,
So
The
it's
X.
y plus x over x plus.
So
x
then-
over,
and again, we can't cancel the x.
No.
Because if we can't factor it out of the numerator, it's not gonna cancel.
That bothers me so much.
Too bad.
Makes
Deal
me
with
very
it.
uncomfortable.
Remove
You must
the
accept
one.
it. Yeah?
I
don't
mean,
want
with
to-
multiplication, we could.
Is that the final answer?
Like if it was y
If
times
this
x.
On the
was
final
times,
answer.
yes, then you could, because it would be like a
Oh,
factor.
yeah.
So, side note,
Side note.
if this was y times x,
Looks sexy.
look, pay attention.
Mm-hmm.
I don't want Mr. Harold telling me you did this wrong next year. You can factor out an x out of the denominator. Whoops. In this situation, and since this is a factor and this is a factor, these would cancel, and you'd get y over y plus 1 plus y.
So the-
And again, these would not cancel because this is not a factor. This is a factor,
So not the final
and this
answer.
is a factor. Right, in that situation.
So, but that's the same as that.
No, it's different because here it's multiply, here it's
Oh,
plus.
oh, I just was looking at the problem. Don't
So
worry.
again, you can only cancel factors. Factors are like think things that are multiplied by other things. If it's not multiplication, then you can't cancel it.
That bothers me.
I'm sorry. All right, see if you can do the U-try. Something that is a fraction, make it a fraction. So I turned x into x over 1, and down here I did the same thing. And that way I can find my common denominator. So in the numerator, your common denominator is y. So you have to multiply this by y and this by y.
Mhm.
And
I figure as much.
in the denominator, our common denominator would be x. So you multiply this by x and this by x. So in the numerator, I get xy minus 1 over my common denominator of y. In the denominator, I get 1 plus x squared over x. Questions about that part?
No, I'm like there now.
I'm there. I just don't know.
So
my
now,
answer.
because this means division, I'm gonna keep change flip. So you keep the numerator. So keep this. You change division to multiplication. And you flip the second fraction, aka the denominator. So you multiply by the reciprocal of the denominator.
Yeah.
Now, if you want to cancel, then you have to factor. If you can't factor, then what you have there is your factor. Now, can I factor this? Can I factor this?
No.
Can I factor this? Can I factor this? So then what you have here, each thing you have is a factor. This binomial is a factor. This binomial is a factor. This is a factor. This is a factor. Are these the same? Are these the same?
No. No.
Are these the same?
Nope.
Are these the same?
Nope.
If you're saying no to all the things, then that means you can't cancel. So all you can do is just multiply the numerators and multiply the denominators. So we get x squared y minus x over y plus x squared y. And no,
Wait.
it's not pretty, but that's what it is.
No. You didn't.
No? Did I miss something?
Wait, and what
You missed
did
it.
I
That,
do wrong?
you only factored the x to one of them. On the
No, I
top.
didn't. This guy.
Yeah, but
So
what about
x
the-
times xy would be x squared y, and then x times negative 1 would be
Oh yeah,
negative
yeah,
x.
yeah. That's what I was saying.
And then y times 1 is y times x squared is x squared y. They look really similar, and that's why I put this here, because I really want you guys to understand what can cancel and what can't cancel. It's like you really want to cancel these, but you really can't. Okay. Alright. Now, we can make them harder by putting more binomials in them
Yeah, let's
instead
make
of
them
just
harder.
like x and y. If you look at the you try, that one's like extra fun. Alright, so again, we're gonna break this up into numerator and denominator. We're not gonna panic. This is the numerator. And instead of saying plus 2, I'm gonna say plus 2 over 1. And then the denominator, I have 1 over 1
Is
plus,
this D?
Yeah.
yeah. X. This is what I got. Numerator over denominator. All I did was I just rewrote it so that 2 and 1 are fractions. So what we'll do is we'll simplify the numerator. We'll go all the way with the numerator till we can't go anymore. Then we'll do the denominator, and then we'll put them together. That's the plan. Okay. Numerator. Ignore the red. Just close your eye and be like, I don't see that there at all. If I want to combine those fractions, I need a common denominator. This denominator is x plus 4. This denominator is 1. They have to be the same. So I need to multiply by,
X plus 4.
right, and I'm going to multiply here and here. So I get 2 over x plus 4 plus 2x plus 8 over x plus 4. I distributed. Then when you add those together, you get
2x plus 10?
mhm,
Which factors a 2?
it does factor.
So do you wait or do you do it now?
Up to you.
I'm just gonna wait.
Yeah, I'm gonna wait too. And so we've combined the numerators, that's our goal. So your goal of the numerator is to find a common denominator, combine the numerators, and then you'll do the same thing to the denominator. So in the denominator, we have 1 and x plus 4. We want those to be the same.
X plus 4.
So you have to multiply by x plus 4. So that gives me, so 1 times x plus 4 is just x plus 4.
Doesn't that go to 1?
Huh?
Doesn't that go to 1 though?
No, you just leave it in one, I think, right?
What do you mean? Does what go to
Like x
1?
plus 4 over x plus 4.
Well, that would be going backwards. We don't want it. We want it, remember, the whole point of finding a common denominator is so we can combine the numerators.
Gotcha.
So we don't want to simplify, we want to combine numerators, we want to add. So we're going to add now. So this is going to be x plus 7 over x plus 4.
Let me know why I wrote through x plus 12.
Oh my god.
Because you multiplied 3 and 4. So we have like one fraction divided by one fraction. So we've done a lot. Now we're going to make the compound fraction one fraction. So we're going to keep the numerator,
So far I'm doing great.
and instead of dividing, we're going to multiply by the reciprocal of the denominator. So that's going to be x plus 4 over x plus 7.
You can cancel the x
That's
plus 4, but after you take the
Wait, real quick though, because Tristan was saying earlier, this factors. Before you cancel anything, you want to see if you could, so, okay, go back in your mind to when we just did multiplying rational expressions. What was step 1? Factor. So this should still, that needs to still be the same thing.
Oh, I did. It just didn't work.
So, right, you did, it just didn't work.
Yeah.
But in theory, that's what you want to do. You want to factor if you can, because sometimes it does work, and you want to make sure that you go through that process. The only thing that factors is that guy right there. Now,
So we would leave it as the 2x plus 10 as we multiplied, right? 'Cause
right, so if it's not helpful to cancel,
Not.
then just ignore it.
Okay. Good
Okay.
plan.
So
If
then-
it is helpful, great, then you can cancel something. But in this case, it's not helpful, so
then
we don't
does
really need it.
the x plus 4 cancel?
I'm gonna write not helpful. So this is a factor, this is a factor, these will cancel. And you get 2x plus 10 over x plus 7.
And that's just the answer. 'cause
And
there's
that's
no-
your answer.
See, that one was easy.
Was it? Good.
The one.
Wait, isn't x
So-
plus 1 times x minus 1 just 0 or 1? Just 1?
No, that's not how that works. We're
It's
gonna
not.
find a common denominator here. So if this denominator is x and this denominator
yeah,
is
what
x
did you
plus
do?
1, since this is a factor and this is a factor, you have to multiply by each other. So this one we're gonna multiply by x plus 1. This one we're gonna multiply by x. When you multiply x minus 2 times x minus 1, or x plus 1, you have to FOIL, because these are binomials.
Mm-hmm.
So when you FOIL, you get x squared minus x minus 2. And we're going to add that to 2x. And when we add that to 2x, you're combining, since it's addition, this is a negative x, that's a 2x, you get x squared plus x minus 2, all over your common denominator. Don't distribute your common denominator, you're just gonna
Yeah,
factor it later, but it's fine if you did, but you're just gonna have to factor it. Okay, so once you get your numerator as one fraction, get your denominator as one fraction. If this is an x minus 1, and this is an x plus 1, this needs to be multiplied by x plus 1, and this needs to be multiplied by x minus 1. And so, this numerator becomes 3x plus 3 over the common denominator. This numerator becomes x minus 1 over the common denominator. We're going to subtract. Now when you subtract, you're doing 3x plus 3 minus x plus 1. Because you have to distribute the negative sign. And so you get 2x plus 4. And you do that.
Wait, I got x minus 1.
Where?
That was really unspecific. Just
Yeah, where? So now we're going to keep the numerator, and I'm going to factor it. So keep the numerator and factor. You're going to get x plus 2, x minus 1. We'll change division to multiplication, and then flip that fraction. So you put the 2x plus 4 on the bottom, which factors. Okay, so factor everything and keep change flip. And then cancel. We can cancel x plus 1 and x plus 2. And that's it. And on top, we're left with 2 x minus 1s. On the bottom, we're just left with 2x. So you can leave it like that, or you can FOIL it out. Get that as your answer.
Is there a way you prefer?
Not really.